All right, so I just want to let you know that I recorded some of this at school, some of this with my document cam. When I got home, I had my microphone that I got, so my volume is kind of changing. Bear with me, you know that I'm a work in progress. I'm always trying to improve, so kind of excuse my audio. The next one will be better. Okay, so we're working on 5.6, inverses of functions, and this is a lot of practice with our Algebra 1 skills. So I'm going to do monitoring progress 1. F of x equals x minus 2, and then we're going to first solve for x. So we're going to replace f of x with y. So y equals x minus 2. And then we're going to use some basic algebra skills and solve for x. So we're going to add 2 to both sides. So y plus 2 equals x. Perfect. Now we're going to find the input when the output is 2. That means the output, if you remember, is y. The input is always going to be x. So I'm just going to replace 2 here for y. So 2 plus 2 equals x, which is going to equal 4. Pretty simple. Okay, let's move on. We're going to do monitoring progress 3. So f of x equals negative x cubed plus 3. Okay, replace f of x with y. So y equals negative x cubed plus 3. Subtract 3. So y minus 3 equals negative x cubed. Then divide everything by negative 1. So negative y plus 3 equals x cubed. Now we still have to solve for x. And if you remember, we're going to cube root both sides of this. Cube root. I'm going to move my work up here. So now the cube root of negative y plus 3 equals x. That is my answer. So now we're going to plug it in for we're going to find the input when the output is 2. So remember, you put the 2 here. So it's going to be the cube root of negative 2 plus 3 equals x. That means it's the cube root of 1, which is going to equal 1. So it's a two-step process. First, you have to solve for x. Then you have to plug it in and find the input. Okay, so this is a screenshot from page 277 from your textbook. I just want to explain a couple of things here for you. So, inverse functions are functions that undo each other. So that's kind of a key thing to understand here. They undo each other. They're called inverse functions. So, we will go over how to find the inverse of a function. But let's say here's the original function, f of x, and then here's the inverse function. Now when we plug in points for f of x, and then we graph it right here, and then we plug in points for its inverse here in red, and then we graph it, I want you to notice how the line is reflected over y equals x. So y equals x is called the line of reflection. So if I were to fold this paper right here on the dotted line, these two functions should match each other. They will be mirror images of each other. And now let's take a look at the table. Look at my points here for my original function. If x is negative 2 and y is negative 1, take a look for the inverse. X is now negative 1 and y is negative 2. In other words, each of these points, the x's and the y's switch. That's what makes a function an inverse, if it's exactly the opposite points that are switching from the original one. So let's do some problems. Doing monitoring progress 4, we're going to find the inverse of this function and we're going to graph it. So first step is replace f of x with y. So y equals 2x. Step 2, switch out the x and the y, so y is now x. and x is now y. And then you solve for y, which means you're going to divide both sides by 2. And I'm just going to write it so it looks like this. Y equals x over 2. So that means that my inverse function, with that negative 1 up there, is x over 2. So remember, if we picked plots and did this by hand, so there's my first function. If I pick 0, y is 0. If I pick 1, y is 2. If I pick 2, y is 4. Now let's do the inverse, x and y. If I pick 0 for x, y is 0. If I pick 2 for x, y is 1. If I pick 4 for x, y is 2. So now you can see when you're trying to compare the two of them that the inverse function points are exactly the opposite. We're going to plug this into our calculator so you could see it reflect over x equals y. Okay, so here I put into my graphing calculator my first line of symmetry right there, y equals x. And then I put in my first function and its inverse. I press graph, and if you notice, the blue one, there we go, is my line. And then here is my function and its inverse. So remember, if I were to fold it along the y equals x, it should mirror exactly each side. Monitoring progress 5. So let's replace f of x with y. So y equals negative x plus 1. Now switch x and y. So x equals negative y plus 1. Now solve for y. Step 2. I'm going to subtract 1 on both sides, which equals negative y. Then I'm going to divide everything by negative 1, which changes this to negative x plus 1 equals y. So that means that my inverse function is negative x plus y. So I'd like you to pause the video, use your graphing calculator. I want you to plug in the original function. I want you to plug in the inverse function, and I also want you to plug in the line of reflection, which is y equals x. One more, monitoring progress 6. F of x equals 1/3 x minus 2. Replace f of x with y. Now switch the x and y's. X equals 1/3 y minus 2. Now let's use our algebra 1 skills. It's going to be x plus 2. Remember, add 2 to both sides is 1/3 y. And then how do I get rid of this? I'm going to multiply both sides by 3. That's in its reciprocal. And that's going to be 3x plus 2 equals y. Oh, sorry, my mistake. Let's go back. 3x, forgot to distribute, plus 6 equals y. Perfect. So that is my inverse function. And again, I want you to pause the video and plug it into your graphing calculator, as well as the line of reflection, which is y equals x, and see if those two lines mirror each other.